This is number 5 on the 8.6 worksheet. So we've got a set of test scores, and those are normally distributed with a mean of 100 and a standard deviation of 20. We want to use the empirical rule to find the percentage of scores in each category. So I'm going to do the first 4, A through D. So the first is less than 100. So normally distributed means that we are working with a a bell curve, which looks something like this. And let's make that a little bigger. Okay, so we want to start labeling where the mean is in our standard deviation intervals. So our mean, that's right in the center, that is 100, and standard deviation of 20. So let's go ahead and go up and down 3 standard deviations, because that's typically what we want to look at. So if we go up 1 standard deviation, we add 20 to 100, so that's 120. If we go up another one, that's 140. And lastly, third up is 160. If we go the other way, 100 minus 20 is 80, minus 20 is 60, and one more, minus 20 is 40. Okay, and again, this center line, that's the mean. So we want to know the percent of people that have less than 100, or score less than 100. So if you look at the graph, this is split right in half at 100. So the percentage of people that will lie within this region is 50%. Okay. Let's copy this. Okay, let's look at the next one. Okay, this is less than 140. So let's paste our bell curve. Okay, we're using the same data. So less than 140, that is going to be all of the area to the left of 140. So we need to remember what the empirical rule says. So the empirical rule says that if this is our mean, if we go over 1 standard deviation, the area under the curve between those two numbers is 68%. Okay, if we go over another standard deviation on either side, the percentage in there will be 95%. And if we go over a third standard deviation on either side, that contains 99.7%. Okay, so we know using the empirical rule that this between 2 standard deviations on either side of the mean, that's 95%. So this section right here has 95%. And so we need to know what is the area right here within that region. So there's several ways you can do this. One way is to know that this section right here is 50% of the data. And again, we know that this section is 95%. So let's divide 95 by 2 to find out what this section is. So let's see. 95 divided by 2 is 47.5. So this section is 47.5%. So that means that if this is 47.5% and this is 50%, that means this section has to be the remaining 2.5%. I think 50 minus 47.5. Yeah, that is 2.5. Okay. So what we can do now is we can add this 95% plus this 2.5% right here. And that will give us 97.5%. Now, you also could have just taken 50% and added this half to that, and we know that this half is 47.5 because it's half of 95. So if you do 50 plus 47.5, you would also get 97.5%. Okay, let's look at C. Okay, greater than 60. So greater than 60 is going to be everything here. So again, we know that from here over is 50%. We know that between these two standard deviations on either side of the mean is 95%. Okay, so really, this is kind of similar to what we just did. We need to take this 50% and add these two standard deviation areas to the 50%. And we know half of 95 is 47.5 because we just did that. So we can go ahead and just add 47.5 to 50. So again, we get 97.5 oops, that's supposed to be a percent sign. Sorry, it's kind of hard to draw with this sometimes. Okay. Alright, let's look at the last one. Let's paste our curve on here. Okay, greater than 80. So that's going to be from 80 up, so that section. Again, we know that from the halfway mark up, that's 50% of our data. So we need to figure out what this little slice is to add to 50. We know, using the empirical rule, that between one standard deviation on either side of the mean is 68% of the data. So we need to find half of that to know what this little section right here is. 68 divided by 2 is 34. So that little section is 34% of our data. So all we have to do is add 34 to 50, and we will get, that's 84%. Okay, so what you're doing with these is you're using the empirical rule to know what percent of the data is between certain standard deviations. A lot of times you're using that half of the curve is 50%, and then you're adding that portion of the percentage to 50%, or you might be subtracting sometimes.